Hello, this is the HARP Report, and I have just found the most incredible and amazing proof of weather control using the ionospheric heaters. What we're looking at here is GOES 16 visible light, September 24th, 2018. This is a week or so after Hurricane Florence, and this right here is a low pressure, a surface low, building up the morning of the 24th, and it is really going to form another hurricane just like Florence. It would be just a carbon copy. And let me show you what I'm talking about. This is the most astonishing and incredible proof of the ionospheric heater destroying a low pressure center that I have ever seen in my 5 years of watching these satellite maps. I'll slow that down a little bit. Okay, so we notice this part of the low pressure, the surface low, disappears. Okay, so now it goes back to daybreak. Let me blow this up a little. This is so astonishing, I can't believe it. It's a gift from the GOES software people to let us see this. Okay, so here we see a lot of thunderstorms, hundreds of square miles of thunderstorms building up, and if we look at the jet stream, you can see in this area here, there's no jet stream aloft. So it's pretty much ideal for hurricane development right here. Plus, the water surface, sea surface temperature is outrageously warm. We're talking, looks like 84, 85, and this blue is just the cloud tops. So you have to just look at the solid parts. And that looks really more like 86, 87. So this is absolutely prime to form a second Florence in about 10 days. And the surface pressure map is of course showing a low pressure building rapidly on the 24th. So let me show you this amazing thing. Okay, so at daybreak, the D layer of the ionosphere is just reforming in this area, because the sunlight's hitting it and energizing the, causing this electron separation about 50 kilometers up, and then the big Navy ships can start hitting it with a microwave beam. And what they did, let me ask you to look right here in this area, and I would blow it up bigger, but then things get pixelated and it's actually harder to see. So alright, so we see some arcs here, some concentric arcs, and there is a divot right here. So let me back it up. You can see a stationary divot in the cloud top. Maybe I will blow it up one time and center it forward. You can see the divot, and then some waves travel outward. Concentric waves coming out from that divot backwards. Forward. Darn, it does get hard to see when you blow it up. I have to make it smaller again. Something about the pixelation changes the contrast. There, now it's visible. And forward again. We're looking right here. There's a divot. And then the circular roll clouds, HARP downburst roll clouds, radiate away from that at a specific speed. Let me go forward. Okay, so these waves right here, you can see them clearly. There are three concentric arcs here moving away from that center divot. And meteorologically speaking, there is absolutely no way to explain that, because we're talking a super localized high pressure of downburst of air, so you can't really see it when it's too big, the pixelization. Okay, this is actually better. Smaller is better to see it. You might have to go full screen on this. But what they're doing, these big Navy ships are heating the ionosphere right here. 50 miles up, it expands rapidly and actually pushes down on the top of the jet stream, and we're seeing this divot in the clouds. And then some 30, 40, an hour later, these roll clouds propagate outward, and we can see how many times. Let me just go back and forth right here. So you can actually see that? There's a stationary spot in the top of the clouds. That's the ionospheric heater divot. Let me make it bigger and see if we can watch that. Back, forward. But you can see right here, there's something stationary. Everything around here, this is cloud tops, 30,000 feet up, and everything's moving except this divot. How can that possibly be? It's because the ionospheric hotspot is stationary. Forward. You can see it clearly there. See that is a stationary hotspot with a divot. And so they're actually blowing a hole in the ionosphere that's thousands of miles in area, thousands of square miles. So here you have this low pressure leading edge building up here, and they hit it with the ionospheric heater, create artificial high pressure in the jet stream. And then later you have the HAARP roll clouds propagating out from the center. And then that's a really nice view right here. These roll clouds coming clearly from this area right here. And this is a gift from the GOES people that normally they Photoshop this. You'll never see it. For some reason they have given us a gift so we could see it. And then as the morning rolls on, guess what? That upper high pressure takes over and stops all the clouds, all the storm formation in this area. So let's just follow it through to the next morning. Just repeat. Here's the divot. Here's the divot starting right here. Backward. So you can clearly see this arc emanating from this divot right here. So from a meteorological standpoint, this can't happen in nature. You don't get a localized high pressure like that. That's totally stationary. And then what's happening is you have a burst of air hitting the top of the clouds, and it's so solid it can't penetrate, so it spreads outward in these circular roll clouds. And that's just like a rolling pin where you're rolling out pizza dough on a counter, but it's turning the opposite direction. Okay, folks, so anyway, this is and actually the bigger you make it, the harder it is to see. See, now it's very visible. See, the divot stays there stationary. Daybreak, heat the ionosphere, you get a jet of gas pressing down, then you get the roll clouds propagating out from the center. So this actually probably was photoshopped, because we could have probably seen a lot more detail, but you can clearly see. And then after that action is completed, a couple hours later, all the storms disappear, and now there's many thousands of square miles where the ozone layer has been disrupted. And I'm going to make my next video will be about the ozone layer and how this type of weather control absolutely does and must punch holes in the ozone layer. There it is. There's the divot. And then it propagates outward. And actually we could count. Let's just count how many of these concentric rings there are, and then we can know how many ionospheric pulses of gas came down and hit. Okay, so I'm going to count. The divot starting to propagate outward, and it's something like it's a definite speed of just like a thunderstorm collapsing, what they call an outflow boundary. It's the same thing, only this is happening at the top of the cloud layer. 1 ring, 2 rings, 3 rings, 4 rings, 5. So I saw 5. Let me let it run and zoom in. Let's see if we can count them. 1, 2, 3, 4. Yeah, see, when you blow it up, the pixelization takes over, because this is how the picture is supposed to look. So that's I've seen this many times in the Gulf of Mexico, where the Navy guys are saying, look, we're doing something good. Hey, look, we're stopping another hurricane. Well, indeed they are right here. But what's the cost? You're going to have another patch of plankton out here that's killed by ultraviolet B. So there is, I mean, I hate to say a benefit. It's not a benefit. You know, the thing about what they actually are doing now, and this is the prime directive out here, is to cool this water so you don't have giant hurricanes, killer hurricanes. And to do that, they take a low pressure and break it up into disorganized thunderstorm masses, and that rain cools the sea surface temperature down. But it only lasts like right here, a week. After a week, you got 85 degrees again and another potential killer hurricane. So it doesn't look like much to you guys probably, but to me this is a stunning event to actually see the divot in the cloud tops right here. This is the divot. That is the jet of air being pressed down from the top of the atmosphere due to the ionospheric heater, and then to have the roll clouds emanate from that center. Absolute confirmation. And then all the storms disappear. Hope you enjoyed this video, and after I found this, I said, oh my God, 25 times in a row. I've never seen anything so stunning as this after 5 years of watching the weather maps. Alright, thanks for watching.